PPT. Any doubts are there in this magnetic field? The magnetic field sensor,
No, sir.
it is a range sensor.
Okay, sir.
Yeah, in this there will be a permanent magnet and it will be sealed by a ceramic so that it cannot able to react with the other side. Once the object is coming nearer, only the important thing you have to remember is the shape of the magnetic flux will get changed and it will be a measure of the distance of the object and the presence of the object. These two will be identified by this. Okay, the next one, the capacitive sensor is also a range sensor. Capacitive sensor is also a range sensor. I had given a previous class one example, the capacitive sensor, which is that? What is that I had given? And this can be used for gases, liquids and solids also. This particular capacitive sensor can be used for varieties of materials. I had given you one suitable example. More than 15 years back, the BHL have developed a gas sensing capacity sensor. It is costing you not more than 600 to 700 rupees. You can keep it in the kitchen, and there is a leakage of the gas. It will be giving you the alarm. So the leakage can be obtained. Correct? No? Very simple. Like that, the unit to project also you can do. Correct? No? You can find in the market the availability, and you can do even redesign and you can do it. Okay. So yesterday in the final round of the hackathon, and there were 9th standard students. They have presented very neatly for the blind and the handicapped person how to make the communication. Correct? No? So that is costing you not more than 200 to 300 rupees, a particular mechanism or a machine by which they can able to interact with the others. Okay, that was at Chhattisgarh. I was the judge for that. Okay, and the capacity sensor can able to identify the liquids, gases and solids also. In its simplest form, it will be having two capacitors. One is a sensitive electrode and another one it is a reference electrode. And capacitor is having what? The two electrodes will be there, and in between that there will be a dielectric medium. Okay, and any presence is there, what happens? The dielectric medium will get changed, and due to this there will be output. Very simple. What happens inside and all, we don't want the circuit. Okay, there will be a reference electrode, there will be a sensitive electrode, and in between them there will be a dielectric medium, and any gases or solids or liquids are flowing towards or passing towards or crossing this capacitor, the sensor. What happens? It can able to identify the object, because how it can do, the dielectric medium will get changed. Correct? The dielectric medium will get changed between the two electrodes. So this will be a sense of understanding the presence of the object and what distance this object is. This is the capacitive sensor. And this other one, this is also called as a triangulation technique. Here are not given a triangulation technique. Why it is called a triangulation technique? The reflection and the array of sensors and the light source are kept in a triangular form, so that it is called triangulation technique sensor, or simply you can say it is optical sensor. I have not given here. You can write a triangulation technique sensor. In its simplest form, please try to see that there will be an array of sensors. Just like you see that it is a scale. You assume that it is a scale of sensor. At every 1 mm or every 1 inches or 1 meter, whatever it is, a sensitivity or range or application for which it is meant for, at equidistance the sensors will be fixed. Now the light source is made to fall onto the opaque surface of the object to be identified. This is the object. Only the condition, please look here, the previous one, the inductive sensors application is it can able to identify only the magnetic particles or magnetic materials. Disadvantages, it cannot identify non-magnetic materials. We cannot use it for the non-magnetic materials. Okay? And the capacitor can be used for anything else. Now here another condition in the triangulation technique or optical proximity sensor is that the surface of the object should be opaque. That means it should be reflective. Once a slit of light, you can see that simply light is not simply ordinary light. A slit of light is, it is forming a ray, a particular ray. This will be a lens or length. What happens? It will be concentrating the light. A simple one line of light will be falling onto the surface of this, and it will be reflected and it will be falling on a particular sensor. Just like I am throwing a ball from here, it will be just bouncing from this and go to other wall. So there will be a relation, trigonometrical relation. You can say this x we know and this y we know, and we can able to find out the length. We can able to find out the length. So that means to say the algorithm which have been developed in these sensors to measure, it can able to measure the angle of the reflection, and this angle of measure or angle of refraction will be a measure of distance. You can see that the reflection is 30 degree and already it has been fixed 30 degree, correct? No, if this distance you know, the 30 degree you know, I can able to find out this hypothesis, hypotenuse, correct? No, correct or not?
Yes, sir.
Yeah, I can able to find out this. So like this, we can able to find out the unknown distance from the light source. From the light source, what distance it is. That means that particular sensor, once it is reflected, that will be sensitive. Once after it is sensitive, the angle of reflection will be measured and it will be giving you, or the angle of reflection will be proportional to the distance of this sensor from the light source. We can able to find out the distance of the object from the light source. Triangulation technique, please remember, triangulation technique, it has come in the examination. Sir has not told, please don't think that. It is optical proximity sensor, or simpler you can say it is a triangulation technique sensor. Since the light source, the sensor and the object are kept in the triangle way, so that it is called triangulation technique sensor. And under these miscellaneous sensors, we will be having pressure sensors and photometric sensors and optical sensors, piezoelectric sensors, pressure transducers, so many other will come under these, all these will be coming. And apart from this, if you want to talk about the machine vision application, if you want to talk about the machine vision application, I don't think that it is here. The machine vision application will be used where? One of you please tell me where the machine vision application will be used. Yeah, machine vision application will be used for assembly and all this. Assembly purpose and all this. Correct, no? And you can see that machine vision, it is not there for you. Just I am telling you the version of it. The machine vision application, it is meant for the assembly and inspection operation. Just in simple word, I'll tell you, there will be 3 stages: sensing and digitizing the image, image processing and analysis, and application. And here there will be light source.